Hello everyone. Today's video we will be looking at the circuit diagram, electrically, the electrical circuit of an electric kettle, which is this one. You may have this one also is electric kettle. You may have lots of electric kettle from different companies, whether it's Bajaj, whether it's Prestige, Elegant, whatever companies that you take in front of you. The circuit diagram is the same. This is the circuit diagram. So first of all, you'll have the phase and neutral, the plug just like this. So this one, and then you have the mechanical switch also, which is your connector, the base of the electric kettle and the electric kettle itself. When you put the electric kettle on top of the base, then this is on like this. Okay, so the base is actually this one. Let me show you where is the base. So this is the base. So when you connect in, it will close the circuit diagram here. All right, and now the phase like that, it come the temperature based on and off mechanical switch, which is basically this one. This is the damaged one. All right, this is the one, the mechanical switch. Okay, this is the outer one is the phase, the outer circle is the phase, the inner ring is the neutral, and the middle is the earthing. All right, now the switch is actually there in the phase, the outer one. All right, like this. Okay, so when you, so this is the switch like this, and then so this is the contact point between the electric kettle and the base. All right, now this is this one is a damaged one, but the other one is still a good one. Okay, so when you have to regarding this, you will have these two terminals, right? This is the phase, and when you measure the connectivity, if this is a good one, the connectivity between this point, which I'm pointing this, and the outer circle should be short. Okay, there should be continuity between this one, and between the inner one there should be continuity between this and this terminal, right? And the middle one is the neutral. It should have continuity between this and this. All right, for a good one. But for a damaged one, this one, so this one is a good one. Okay, so when I test the connectivity between this point and the outer, which is the phase, the outer, remember that the outer circular ring is the phase, right? This should be short. All right, when I test, this is still a good one, so you see it is short. Okay, but when you test this terminal and the inner ring, it will short. Okay, this is the neutral, and the middle one is the earthing, like this. Okay, when you test the connectivity, it should be short. All right, so this is for good one, but the damaged one, see this one, when I test this, it will show some resistance. I mean, there is some carbon sitting, still okay, but this one is totally open. I could not rectify it also. I tried, but then there is still carbon which is left, still remain open. Because of that, the electric kettle doesn't work. All right, there's no problem with earthing, whether it's there or not. That is not our issue. Okay, so this is how the connection of this base and that of the electric kettle connect. Okay, so this is the kettle where I have removed the mechanical switch, which is temperature base. So before I connect a good one, I will first verify whether the resistance of the coil is still okay or not. And remember that this is a 15 watt, so if you our domestic voltage is 230 volts, so if you calculate the resistance on the basis of the rating of on the basis of the watt rating, you should be getting around 35 ohm, right? So let me calculate the measure the resistance of the coil using a multimeter. How much am I getting? Okay, let me put there. Am I getting any value? See, 38, 35. All right, so it's coming 35, which is fine. Okay, how much? 35 ohms. All right, which is coming fine. All right, now if I do it properly, I'll show it how resistance come. See, it's 35, right? So I'm getting 35 exactly, so it's perfect, right? I should be getting 35 ohms. It's perfect. I mean, this coil is still fine, so I need to just replace I have removed this. This is damaged because I could not rectify, also because of the carbon sitting. So I'll throw this. Instead I'll use the good mechanical switch, which is temperature based. I'll use this one. Okay, so this is what I'll be doing. So I am connecting this. I have replaced this, and you'll see it should work properly fine now. Now after you are done with this, when you have already tied this, okay, you have replaced this also with the new and good conditioned mechanical temperature based switch, and then you can test. All right, you have to, before for testing, for measuring the resistance, you have to put this on off button switch. Okay, you have to on this is in off position, right? And when you on, it will be in this position. Okay, and when this is done, you can test from this itself. From this itself, you measure the resistance, okay, of the coil inside, because everything is now on. If you look at the circuit, everything is now on, and then when you measure the resistance, your multimeter should read 35 ohms. Okay, between this, okay, this point, outer circle, and the inner one. Okay, phase and neutral, you are measuring and how much your is reading. Because of carbon resistance also, you should get around 35. Okay, you are getting 36, is slightly increased because of the contact resistance also, which is there. So you are getting 36 or 35.9. okay, that roughly it fluctuates, but ideally it should be 35 considering the contact resistance is 0, but 36.1 is still good. Okay, and because of certain contact resistance, and the watering also will reduce slightly. Okay, so this is good. Okay, like this only. And when this process is complete, then what you can do, you can see, you take this base and then you put the electric kettle like this, you connect like this. Okay, to ensure that the circuit is complete, just like I've already shown you the circuit like this. And you take this this plug point like this, and when you on this, okay, remember that you have to on this switch. Okay, this one, and when this is on, and in the same way, when you measure the resistance of the coil, and if you neglect the contact resistance, you should be getting around 35 ohms. Okay, and I measure like this, how much you are getting. It's coming 38.5, and this is because of contact resistance. Had the contact resistance been 0, we would have got 35 ohms exactly, but due to a certain certain contact resistance, we are not getting exactly 35, but it's slightly more, which is okay. All right, so this is the line and neutral, the phase or the neutral. All right, so like this, and this complete the repairing process of this electric kettle. And this is same for all electric kettle, no matter what shape they are, and no matter from which company, whether it's Bajaj or whether it's Prestige or Elegant, whatever company that you will take on your table, they will always have the same circuit, and the only difference is just the quality of the coil, the quality of the switch, and the quality of the the contact resistance. And because of these, the longevity or the quality of the product also differs. All right, so this is how you repair an electric kettle. All right, so thank you.